Hi guys, today we discuss what on earth is fusion energy. Before we start, like and subscribe to our channel and press the notification bell so you don't miss the next video. Our current energy landscape is heavily dependent on the fast-depleting fossil fuels, with 80% of the global energy consumption being based on fossil fuels, and changing this dependence is critical to meet the growing energy demands and to cut down on the greenhouse gas emissions. Once harnessed, fusion has the potential to be a nearly unlimited, safe, and carbon dioxide, CO2-free energy source. On the Sun, the process of fusion is driven by the Sun's immense gravitational force and high temperatures. But the Earth does not have the immense gravitational force required to confine the hydrogen nuclei, so a different approach is needed to achieve fusion reactions on Earth. Nuclear fusion is the process by which two light atomic nuclei combine to form a single heavier one while releasing massive amounts of energy. Fusion reactions take place in a state of matter called plasma, a hot, charged gas made of positive ions and free-moving electrons that has unique properties distinct from solids, liquids, and gases. To fuse on our Sun, nuclei need to collide with each other at very high temperatures, exceeding 10 million degrees Celsius, to enable them to overcome their mutual electrical repulsion. Once the nuclei overcome this repulsion and come within a very close range of each other, the attractive nuclear force between them will outweigh the electrical repulsion and allow them to fuse. For this to happen, the nuclei must be confined within a small space to increase the chances of collision. In the Sun, the extreme pressure produced by its immense gravity creates the conditions for fusion to happen. The amount of energy produced from fusion is very large, 4 times as much as nuclear fission reactions, and fusion reactions can be the basis of future fusion power reactors. Plans call for first-generation fusion reactors to use a mixture of deuterium and tritium, heavy types of hydrogen. In theory, with just a few grams of these reactants, it is possible to produce a terajoule of energy, which is approximately the energy one person in a developed country needs over 60 years. In order to achieve fusion on Earth, gases need to be heated to extremely high temperatures of about 150 million degrees Celsius. That is 10 times more than the temperatures in the Sun's core. Fusion researchers have established that the easiest to accomplish is the fusion reaction between two hydrogen isotopes, deuterium, which is extracted from water, and tritium, which is produced during the fusion reaction through contact with lithium. When deuterium and tritium nuclei fuse, they form a helium nucleus, a neutron, and release energy. Fusion scientists have developed methods that are able to heat plasma to temperatures of 150 million degrees Celsius. There exists no material, however, that can contain plasmas at such unimaginable temperatures. So, different plasma confinement methods are used by fusion scientists. One of them is the magnetic confinement, wherein the hot plasma particles are contained in a magnetic cage, made by strong magnetic fields, which prevent the particles from escaping. For energy production, this plasma has to be confined for a sufficiently long period for fusion to occur, while the Sun's massive gravitational force naturally induces fusion. Without that force, a higher temperature is needed for the reaction to take place. On Earth, we need temperatures exceeding 100 million degrees Celsius and intense pressure to make deuterium and tritium fuse, and sufficient confinement to hold the plasma and maintain the fusion reaction long enough for a net power gain, i.e. the ratio of the fusion power produced to the power used to heat the plasma. While conditions that are very close to those required in a fusion reactor are now routinely achieved in experiments, improved confinement properties and stability of the plasma are needed. Scientists and engineers from all over the world continue to test new materials and design new technologies to achieve fusion energy. Nuclear fusion and plasma physics research are carried out in more than 50 countries, and fusion reactions have been successfully achieved in many experiments, albeit without demonstrating a net fusion power gain. How long it will take to recreate the process of the stars will depend on mobilizing resources through global partnerships and collaboration. The most advanced and best investigated fusion device design available today is the tokamak. Tokamak is a Russian acronym for the term a torus-shaped vacuum chamber surrounded by magnetic coils, which create a toroidal magnetic field. The largest operating tokamak today is Eurofusion's flagship device, the Joint European Torus or JET. It is located in the Culham Center for Fusion Energy. ITER, the biggest fusion experiment, being built in Cadarache, France, is also a tokamak. Once operational, ITER will demonstrate the feasibility of fusion as an energy source. So guys, that's it for today. Hope you enjoyed the video. In the end, don't forget to like and subscribe. Turn on the notifications so you don't miss any more videos. Thanks for watching and see you soon.